So moving on to the next slide, and understanding the need for encryption. So before we look at the need for encryption, I would like to tell the different types of data we have in an Android application, and for which type of data are we talking about encryption. So in an Android application, we have two types of data: data at rest, which is data stored locally on your device, and data in transit. So data in transit means data which transits from your local storage to remote storage through the network. So for data in transit, we have various network security protocols which take care of the security of data. But for data at rest, or data which rests on a device, we need to encrypt that data. And also I want to give a context about the types of storages in Android. So in Android we have two kinds of storage: the app specific storage or internal storage, where the app stores its private data and other apps cannot access it. And the second type of storage is external storage or shared storage, which wherein the app store media, that is pictures, videos, music, or any documents. So apps can like use or access files in external storage of other apps, and even any person can access external storage on a device by connecting them to their machine with a USB cable, and they can use that. So the need for encryption is basically to protect data in shared or external storage, and second, to protect sensitive data of your application, like personally identifiable information like your full name, age, date of birth, address, personal health information like your blood group, your age, and your health history, financial details, your card, debit card, credit card details, enterprise data, etc. And also if you have a rooted or a compromised device, then even though Android supports full disk encryption starting from Android 5, still your data can be accessed or compromised through certain techniques. So to prevent the hacker from getting access to your data, you need to encrypt it. And the last need which I've covered here is preventing users from accessing tokens and keys in your app. So we nowadays the APIs which we use have API keys and OAuth tokens. So if someone else gets access to the keys which we are using in our app, then in that case they might end up using the entire API quota. So to prevent such unauthorized accesses, we need to encrypt these type of data. So moving forward to the next slide, here, the moment you write about, so the moment you write about encryption in Android, you will see that you get this search result coming up, and it's the first search result which comes up. Here, the thing which is wrong with this result is there is a warning associated, which itself shows that the code is not secure. And second and most important thing is there is no logic written here to safeguard your keys. So if secret, but there is no mention of like how the keys are being secured, and there is no usage of Android key store. So this is like one of the challenge with existing encryption API. So let's move on to the next slide. So here you can see like this is me, an Android developer, and basically I know the need for encryption. I understand the need for encryption, but I know there is a challenge with existing encryption process. So, and even I don't know the difference between different encryption algorithms and what to use when, and but I need to encrypt data in my app. So how can I or other programmers who have the similar mindset can achieve encryption? Enter JetSec. So JetSec or Jetpack security library, according to the developer website, provides implementation of security best practices related to reading and writing data at rest, as well as key creation and verification. So by this definition, we get to know that security library does not only provide but it also helps us in key creation as well as storage of the key. So let's have a look at some of JetSec's features. So it assists the developers in key creation and storage. It helps them in encryption operation. It is supported from API level 23 onwards, which is Marshmallow onwards. It allows the developers to protect files which may contain sensitive data like API keys or tokens or other types of secrets, like as I mentioned, PII, personal identification information, PHI, financial data, and it is appropriate for consumer apps such as banking and chat apps as well as enterprise apps. It provides great encryption as well as good performance. So there is a myth around encryption algorithms is that the stronger level of encryption it provides, there is an equivalent performance implication associated with it. But this is not the case with JetSec. JetSec balances great encryption with good performance as well. And it is appropriate for applications in key access. So I'll talk about user presence for providing key access later in the talk. So now, just a minute. Okay, so moving forward to getting started with JetSec. So you can get started with JetSec by including the JetSec dependency in your project's Gradle file. And now, before we dive into JetSec's APIs, let me talk about the double-layer security model of JetSec. So the reason why I have called it double-layer security model is because there are two keys which JetSec uses for encryption. So first, we have more keys to encrypt a file or shared preferences, and it is stored in shared preferences. And it also has a master key or primary key which encrypts all the key sets which are used for cryptographic operation, and master key is stored in key store, a container from where it becomes difficult to extract. So now let's talk about Android Key Store. So Android Key Store is a hardware-backed container, and it stores the cryptographic keys, making them hard to extract. And it stores the keys in a trusted execution environment or a strong box. So by default, it stores the key in trusted execution environment. If you want to store them in strong box, then you need to enable a flag, which I'll talk about later in the talk. And also, I wanted to also inform the attendees about TEE and Strongbox. So TEE or Trusted Execution Environment is part of the processor. It has its own OS, but it communicates with Android OS through a restricted shared storage. And Strongbox is a completely different chip. So the reason the just by the fact that it's a completely different chip, it will actually secure your keys. But because it's a different chip, so there is performance implication associated with it. So that is why it's not a by default storage medium for Android key store, and only if the developer wants, they can enable the flag and they can store the master key in Strongbox. And Strongbox is available on newer Android devices like Pixel 3. So Pixel 3 has Titan M chip. So now let's look at how can we create master key. So master key can be created using master keys class, and we can use the helper method get already exists in the key store. We can get it, or it will create a new master key in the key store. And we need to specify the specification for master key. So by default, it is AES 256 GCM spec, which stands for Advanced Encryption Standard 256 bit. And this is a default, although it's not labeled as default, and the Google team has given reason for that as well, because they right now it's a default, but later they might plan to use some other encryption standard or block mode here. So that's why they have not labeled it as default, but by default this is used for creating a master key. And you get a master key alias when you use this get or create method, and you can use this alias later when encrypting your files or your shared preferences. So one more point to note here is that advanced encryption standard is one of the strongest encryption techniques. And here we are specifying, because this we are using just the default specification, we specify no block mode or padding. And this will work if the size of data is less than the key size or equal to the key size. But if the size of the data is greater than the key size, we will need a block mode and padding. And to achieve that, let us see how we can create a custom master key. So this is how we can create a custom master key using keygen parameter spec. So here you can see we have keygen parameter spec.builder. We specify the key store alias. We specify the key property, which is specifying its purpose, either encrypt or decrypt. So you can write key properties dot purpose underscore encrypt or key properties dot purpose underscore decrypt. And then you can set a key size. So by default it is 256 bit, but you can change it. You can set another key size, so you need to provide the number of bits in your set key size method. And as I said that you might want to set a block mode or padding, so that you can achieve by using this method set block mode. And you can specify the block mode. So here you can see that in the key properties class there is a entry or a field for block mode GCM, and that is being used here. And you can even set up encryption padding. So you can see using the method set encryption padding, from the key properties class encryption padding none is being set. So this means that we are creating a key of 256 bit with block mode GCM encryption padding of none. So we use this keygen parameter spec, and we pass it to the get or create method to get our master key alias. Now moving forward to add-ons for key creation. So as I told earlier, with the Jetpack API, you can even have keys created in your user's presence. So here you can see that we are using keygen parameter spec and the builder. We specify the key store alias. We specify the key properties. So as I said, the properties can be can be either purpose encrypt or purpose decrypt. and then we apply the block mode. Here you can see block mode is block mode GCM. We can apply encryption padding and key size as I told you in the previous slide. And you can add certain other parameters where you require your user's presence. Like you can use this set user authentication required and pass true. So this way you are saying that you need users authentication to be there when the key is being created and accessed. And you can also use set user authentication validity duration seconds, and you can specify the number of seconds value can be any integer but greater than 0. So by this method you specify that after the user authentication is done, till what number of seconds will the key be considered valid. So say suppose user has just authenticated right now through a biometric prompt or PIN or a password. So the key can be accessed within 15 seconds of this. After that, your app won't be able to access the key. So you can specify a considerable number of seconds here. And there are certain features which you can have on Android P and Android Q, and even on Android 11, which will be released soon. So that is set unlock device require true, which you use when you want the device to be unlocked when you are creating your key. And you can also use set is strongbox packed true, wherein you specify that your key will be stored in a strongbox or where your key will be packed up in the strongbox. So you can see all these parameters get passed to keygen parameter spec builder, and you get a keygen parameter spec, and that you pass to your master keys get or create method to get a master key alias. So this way you can achieve creating time-bound keys, creating keys which get created in presence of your user, and creating keys which reside in strongbox. So moving on to the next slide, encrypting files. So you can encrypt files using the encrypted file class, and this class provides custom implementations of file input stream and output stream, and it uses streaming AES to handle files of large sizes, and it facilitates secure reading and writing operations, and it uses streaming authenticated encryption with associated data AEAD primitive of TINK. So basically with encrypting files, we create a file and then we create an encrypted version of it, and we perform the normal read and write operations on the encrypted version. So moving to the next slide of creating an encrypted file. So here you can see an encrypted file is created using encrypted file.builder, and we pass in a secret file, we pass in the file to it. So the secret file, which here you can see, is basically a file instance which is path to a file and name of a file. Then you give a context, then you give a master key alias, and then you specify the encryption scheme. So by default, the encryption scheme is AES 256 GCM HKDF, and then you build it. So this is how you create your encrypted file instance with a normal file. So moving on to the next slide, reading and writing to an encrypted file. So you can write to an encrypted file using open file output, and you can read from an encrypted file using open file input. So you can achieve it in the same way as you read and write your normal files. Only the thing is you are reading and writing to an encrypted file instead of writing to a normal file. So moving on to the next slide, encrypting shared preferences. So this is done using the encrypted shared preferences class, and it's a wrapper around your normal shared preferences class. And this encrypts keys and values using two-stream method. So keys are encrypted deterministically. So keys are encrypted using AES 256 SIV algorithm, which stands for static initialization vector algorithm. And by encrypting them deterministically, it means that every time you encrypt the key, you get the same ciphertext. And values, they are encrypted non-deterministically. They are encrypted using AES 256 GCM. So every time when you encrypt them, you get a different ciphertext. And the reason behind encrypting the keys is some developers, they store sensitive information as keys. So hence there is a facility provided in Jetpack to encrypt keys as well. And one more point which I would like to add here is that the reason why JetSec in the earlier versions has been targeting files and shared preferences is so that they can because in files and shared preferences the data gets stored as plain text. So if anyone gets hold of your data, whether it's in your app specific storage or whether it's in external storage or if it is on a rooted device, so they can get your exact same plain text data. So if you encrypt and store them, then the hackers won't be able to get the data. So moving on to creating an encrypted shared preference. So you can create an encrypted shared preference using encrypted shared preferences, and you do this by using the create helper method. So first you specify the encrypted shared preferences file name. Then you specify the master key alias, then you specify the context, then you specify the encrypted shared preferences scheme for your key, and then you specify the encryption scheme for your value. So you can see for encrypting the key, the default encryption scheme is SIV, which is static initialization vector, and the default encryption scheme for encrypting your values is AES 256 GCM. So moving on to the next slide, writing to encrypted shared preferences. So here you can see that you can write your shared preferences by your normal put string method. You can use edit, and then you can put the string, you can put the key and the data. You can call apply, and in a similar way you can read from your encrypted shared preferences also, like you read from your normal shared preferences using get string and passing the key name. So now let's have a demo of encrypting and decrypting the shared preferences data. So like before we start with the demo, like everyone might be knowing that shared preferences usually they store the data as plain text. Like in the XML, you have your key and your value in the form of an XML. But in this demo, you will see that after they have been encrypted using encrypted shared preferences class of JetSec, they don't get stored as normal plain text. They are encrypted and stored, as well as the key sets. Your key set for your key and your value are also stored in the same file. So you can see, I'll just show it. You can see I've typed a string and I click on encrypt data. So when I click on encrypt data, I'll run you through the sequence of steps which I followed while building this demo. So first I've created a master key, then I've created an encrypted shared preference, and then when I click on this encrypt data button, I'm simply writing to that shared preference using shared preferences.edit. I'm putting the key and I'm putting this data, whatever I enter in the edit text, into that file as a value. And then when I click on decrypt, I'm simply reading from that file using the shared preferences.getString and passing the key name. So you can see that I told you in the previous code snippet that you specify your shared preferences file name here. So in the demo, you can see like your file gets created in your app storage, and you can go and access that file and see the contents after encryption. So you can see I have typed a string, and I have clicked on encrypt data, and I see a message that data is encrypted. Then I go to the encrypted shared preferences file which gets generated, and I see both the key and the value are encrypted. And I even see that the key encrypted key set is there and the value encrypted key set is there. So I want to highlight one thing here, which is that I told you earlier about the double layer security model of JetSec, where we have key sets and we have master key. So your key sets are stored in the same shared preferences file, but your master key always gets stored in your container, in your key store. So even if your app is accessing the master key, for encryption, your app does not know what the key contents are, and it is impossible to pull out that master key from that container. So your master key can never be compromised. That is the level of security of Android key store. And there are other things which are being brought as improvements to JetSec, with the help of which even if one of the keys in your shared preferences file, if any of the key set gets compromised, then also you can perform key rotation and still keep your key set secure. So now let's take a look at the decryption part. So you can see the moment I click on decrypt, it will give me the string back which I had typed in edit text. So now let's move on to the next slide. So this is a glimpse of the shared preferences file after the encryption. And now moving on to what does JetSec use under the hood. So JetSec uses Tink under the hood, and Tink is an open source cross-platform security project from Google, and you can go ahead and look on it at GitHub. So it uses Java, C++, it is available in Java, C++, Objective-C, but Android uses the Java version of it. And it provides cryptographic APIs which are secure, easy to use, and harder to misuse. And few of the features of Tink are key rotation, message signing, hybrid encryption, Mac, Google Cloud Key support, and creating your own primitives. So earlier I told you that if any of the key sets are compromised in JetSec, the Google team is working on to incorporating this feature of Tink, which is key rotation, which is if any of your key sets gets compromised, you introduce certain more keys and simply rotate your key sets. So in that way, you get a new collection of key sets and you can use them. So moving on to what's new in JetSec. So now onwards, Lollipop is supported from July onwards, and master keys class has become deprecated, and there is a new master key class which has come into picture to support new features and new versions of Android which don't have the keygen parameter spec. And you people can get started with JetSec, and if you have any issues you can raise it on to the issue tracker, and the Google JetSec team will look into it. So that was the end of the presentation. Thank you all for attending this, and thank you droidCon Global for giving me this opportunity to present. And for queries, you can ask them after the session, or you can write to me on Twitter or at my email ID. Thank you so much.
All right, Monika, thank you very much for your presentation. As we discussed, I'm going to be making Jan here, my colleague here, the moderator, so that he can present his, we can present the Q&A. So I know that we have some questions here to present to you. So he should be able to share his screen, which will have all those questions on them shortly. Let's see, Jan, if you please do that, then we can show the screens. Nope. There we go. Okay, go ahead, Monika, take it away.
Okay, so the first question is Jetpack library stable to use in production apps? So as of now, it's in alpha, and it's like not being used in production apps because it's not released for production now, but it's alpha, so it's open for like trying it out, testing, and even raising issues, and even asking for more features which developers expect from the encryption point of view, and any limitations to it. So one of the limitations which came up recently was that it was supporting, it was getting supported from Marshmallow onwards, but right now the Google team is working on it, and they have supported Lollipop, and they also intend to move to KitKat for it, for supporting it. Yeah, and also there I feel that right now it's provided for file shared preferences. Maybe later they might extend it further. So these are some of the, like, one of the limitation which I could think of is in terms of the like version which it is supporting. And yeah, one more limitation is that the API is under continuous slight changes. Like earlier it was master keys, but a month ago it got changed to master key. Is there a simple second question is there a simple way to encrypt simple strings which are not stored in files or shared preferences? So like, yeah, if you want to share in Loom database. So Jetpack actually provides the API for encrypting files and shared preferences only. But yeah, in Android, there are ways through which you can encrypt or decrypt simple data. Like as I showed you earlier, one of the common or popular Stack Overflow post on encryption. So you can try that. And also for database, also there are certain third-party libraries which offer database encryption. A third question is, does Jetpack utilize anything from Android JCA, or is it a fresh implementation? I have a couple of questions I will shoot during the talk. Okay, so Jetpack actually uses your Android key store, and it has its own API. And it's a, like, in terms of API, it's a completely new API. And in terms of store, like key creation and maintenance, so for key creation it's a new API, but for storage, key store has been there in Android since long, and it is using that key store. It is using the the powerful security which it offers uh, uh, for key storage, and that is a big advantage of this API. Does the next question is, does get or create for the key need to be synchronized by the developer, or is it handled by the library? So get or create is handled by the library. So if you happen to look at the implementation of get or create in the library, you will see that it itself handles like whether there is an already existing key in the key store, and if not, then it creates a key and sends to the developer. So it handles the synchronization on its own. Next question is this master key per app, and can the app process ever get hold of it? So yeah, it is master key per app, and your app can actually access the master key through an alias, and it can use it for encryption operations like I showed in encrypted file and encrypted shared preference. You can pass the master key alias and get your encryption done. But yeah, you cannot access the master key contents, and nor can you pull out or move that master key somewhere else on your device. So moving on to the next question, should then encryption and decryption happen on a background thread by default, or do we need to spawn background thread assets? I think you will need to spawn a background thread yourself, because as far as I know that it's not handled in the library, but maybe even I need to look at it more. But as far as I know, right now you need to handle it. And can we do encryption on a content provider using JetSec? So content provider is like mainly for you share data amongst multiple apps. So in when you are sharing data amongst multiple apps, in that case you shouldn't use JetSec, because the other app needs to know the keys and all to decrypt it. And if you are using within the app, then JetSec is not meant for encrypting or decrypting keys or simple strings. It is meant for encrypting data in shared preferences and files. Like as of now, the API is limited to encrypting only shared preferences and files related data.
Well, excellent.
So
Thank you, Monica. It looks like we were able to get through all of the questions. Please note that that link is still active then for, it'll be reset for Alexey's presentation coming up. In fact, I'm going to make Alexey our new speaker right now so he can share his slides. Monica, thank you so much for being with us. We really appreciate you being here to share your expertise about the JetSec with us. Appreciate it very much. We'll invite you to turn off your webcam now, and we'll have Alexey on here. I think we see Alexey there calling us in from Moscow today. As I again need to apologize to everybody at the beginning. We had a slight problem with the transmission on this. You were just seeing the slides instead of audio, and I had intended to do an intro reminding that Alexey is going to be talking about how as a team about 2 years ago they decided to create a new application without RxJava, but using view models, live data, and coroutines, a lot of things that were in beta. So we're looking forward to this presentation. I think it's going to be very exciting. And I'm going to click away here so that we can get started. Please remember to use Slido for the questions. Also, just as a quick reminder, Slido should only be used for actual questions about the presentation. Please don't use Slido to make any comments to other attendees or general comments. Please use it only for questions. So Alexey, the time is yours, and we look forward to hearing from you. Go ahead.
Okay, thank you. Hello, everyone. My name is Alexey Glukharev, and I'm Android team leader and co-founder at NovoOcean. And one of our clients is Itigo. And working alongside with their in-house team, we have been developing an application for Android. And for this application, we use live data, coroutines, and now Flow. In this presentation, I'm telling you how we use those technologies and show you evolution of our architecture and evolution of tech stacks that we use for this project. Also, I will tell you how we move from approach of using live data everywhere in every layer of your architecture to use Flow in your domain and data layer. And maybe I will tell you a bit more about live data, how we can replace it with something else. Yeah, we started in 2017, and 2017 was a year of big announcement. On Google I/O, Google introduced Android architecture components, and later that year, in September, they published the stable version. Also, on Google I/O, Kotlin introduced as a supported language for Android, and also that year on KotlinConf, coroutines were introduced. So according to this point and many others, we decided to use tech stack in Itigo. But before I started to tell you how we actually use it, let's revise our initial architecture to be aware about our project. This regular MVM architecture have view model, and model, and you can use data binding to communicate between view and view models and some data. But in our case, we create a separate class called binder, which basically bind our view and view model. And in our case, view model expose live data, and we observe these values from live data and set it to view. Also, on our initial architecture, we use live data to communicate between view model and model. In our case, it was repository. And see in the code, this is our binder class. We decided to move logic from binding our view, live data to view in separate class, and this this thing make our activity and fragment simpler and more useful. And let's see what we have here. First of all, we have a bind method where we bind view, Android view on our view class. This can be root view of your activity or fragment on some container view of some part of the screen or something. Then we bind lifecycle. Basically, we bind live data and receive values from live data from our view model and set values to our view class. The same we do for router events. We receive events by using live data which exposed by view model, and say router do some navigation. Our view class is quite simple. We have a binder method here which bind our Android view, and then a list of methods to set some values to particular Android views. For example, set titles or errors or something else. Our view model is also quite simple. We have a list of live data to set some values to view. We can set items, for example, to our recycle view, show error, or show or hide loader. Also, we receive some values and some data from our repository, then handle this data and send portion of this received data to particular live data in our view model. Our repositories looks like quite complicated, but it's also simple. Actually, see, our repository in our initial architecture also exposes live data, and this mutable live data, and this, okay. And also it has a fetch method using coroutines, and this fetch method basically calls the API. We use retrofit, and for retrofit call interface, we create our own extension to do something in background, which provide a list of callbacks. Callbacks to do some stuff in background using coroutines with particular coroutine scope, and some callbacks to success and error, which result of these callbacks we set to our live data. And before I will tell you how we do it in background using coroutines in our initial architecture again, let's recap our knowledge about coroutines. Here's a few lines of our regular code, this sequential code, and our fetch data method or function. Yeah, this quite heavy method, and we do some, for example, API call there. And if we do this way, we block our main thread and our screen will be frozen. But if we cover this with launch block and started with coroutine and also fetch data method, we mark as a suspend method or suspend function, it will be slightly different and better for us using coroutines for sure. So let's see. Let's start launch our coroutine, and our fetch data will be executed asynchronously as a suspend function. Then on the main thread we do on draw, our screen is able to interact with the user, everything is okay. And then if our data, we will receive the data in our fetch data function, we just set it to our show function in the main thread. So nothing blocking UI thread, everything good. Our code looks like a regular sequential code, but it's working asynchronously. Great. The other thing which is great for coroutines, that coroutines launch in specific scope. And fortunately, KTX extension provides us two built-in scopes. It's view model scope and lifecycle scope for activity and fragments. Also, another great thing, but we can launch as much coroutines as we ever need. And when we decided to close the scope, we will close all of coroutines that assigned to this scope. Yeah, this is great. And during execution, we can change dispatchers. Basically, we can change the thread where we execute our coroutine. We have four dispatchers, but 3 of them more significant for us. It's IO dispatcher to do some network calls, working with files, main for main thread, and default to some computation and CPU. It's pretty simple, like computation scheduler in RxJava. So let's see our code of our extension. First of all, we launch our coroutine and specific scope that we provide to this method. Also, keep in mind that we should put a try catch block inside this launch block to be able to catch exception. Then we call retrofit. We call retrofit synchronously because we need to have control of our execution. And in case we need to close this scope, we close this execution. So we execute this call with context of IO dispatcher in IO dispatcher thread. Then if our response is successful, we switch our context to default dispatcher and do computation in our background suspend lambda. And the result of this lambda we send to our success callback. Otherwise, if our response is not successful, we set exception to error callback. Pretty simple. Yeah, as I said, we used live data everywhere as our initial architecture. And working with live data, we also keep in mind that live data is data holder, which means live data holds the value and the last value actually. And also live data aware about life cycle. And here is a few special case of using live data due to these constraints. First of all, live data have a few base methods. It's set value and post value. Let's start from post value method. This method designed for posting values from the background to the main thread, as far our live data is working in the main thread as usual. And if we call post value method in thousands of times, we'll receive only last value or just portion of. So we basically can rely on only the last value. It depends on the scheduler and how you reload your main thread. With set value method, it's slightly simpler because we can set 1,000 values and we will receive all of them. But again, keep in mind just live data is data holder and depends on the life cycle. Let's see why. Here is example of code with activity and simple view model. And let's see what is going on here. Let's create our activity, and on create method, we probably inject our view model. And in each block of our view model, we start to emit some action in our live data. Emit the loading action, then emit success action, probably with some useful data. Also emit the scroll action. Our activity keep we still in on create state. Then we initialize our observer, and observe result of our live data, but we still receive nothing. And only then our activity in on resume. Our observer became active. Only then we receive the value. And as far as live data is data holder, we receive only last value. And last value for this case is scroll. We missed loading and success. So this in this case, live data is useless for us and we miss some values. Yeah, keep in mind this case. And don't use live data for big objects because live data keep this object in the memory, and if you send to live data big object, you will keep it in memory. And working with live data in activity, it's quite simpler, but if we start working with fragment, it's more complicated. Actually, in twice complicated than activity, because fragment have two type of life cycles. First of all, it's a fragment life cycle. You know about it. Fragment created, attached, view created, view destroyed, fragment destroyed, etc. And the second one, it's fragment view lifecycle. It means we start this fragment, create view, then we move to the next fragment. Our previous one was view of the previous one was destroyed, recycled, and when we go back to the previous one, and we see, and our view will be recreated. Only view, not just the whole fragment. And for our live data, it's useful to use a view lifecycle instead of the lifecycle of the whole fragment. How to do it? Here's a line of code where we observe values from our state live data, and this is instance of our fragment. To use a view lifecycle, we can replace this instance with view lifecycle owner. Pretty simple. Yeah, okay. We can set data, receive data. Everything is good, but for some cases we need to transform data, map data, or convert it to different one. And also, we previously working with RX Java and have a lot of transformation operator like a map, flap map, etc. So can we do the same for live data? We can do, but yeah, live data is for main thread. Keep in mind about it. But yeah, we have two options. First option, to use mediator live data and do everything by yourself. Mediator live data use one live data as a source, and you can observe this source and emit some values after some transformation. And also for some simpler transformation, we have built-in solution using a transformation like a map and switch map. And for complicated case, you can create your own extension using mediator live data. In our project, we have a bunch of them for any cases, actually. And some of commonly useful and that I also use in public code, I put it in my repository. You can find it using this link. Okay, we can do transformation, but all of the transformation executed in the main thread, it's useless mostly for us. But can we use the same for the background? And here our initial solution, it was 2 years ago. We create extension for live data using coroutine. We launch our coroutine with IO dispatcher and do everything in IO thread. Then call the background lambda, suspend lambda with value of particular live data, and then switch context to the main thread and set value in the regular way. Okay, but maybe there is a better solution in nowadays. Yeah, fortunately, Jetpack provides us better solution, and this is a coroutine live data. We can use this dependency in your Gradle file to include this library. You have to use it. Here is our previous code from the callback world with a list of callbacks and the custom extension method, and how we can rewrite it with coroutine's live data. So we start to build a live data builder, which use coroutine's live data under the hood. We can, create this live data block. Then we set some coroutine context, and in our case, we also need to set dispatcher IO to execute it in IO thread. And then we fetch some data from API in our case using suspend function. Fortunately, Room and Retrofit currently support suspend functions. Then if we have some result, we can map this DTO object and convert it to domain object or whenever we need, and emit the result list as a result object, or just a list if you need it. And then try it with try catch block, and in case of some exception, we emit this result with exception. Also, for one-shot operation, when we expect to just only one value from our repository, it can be success or error event, we can mark our suspend fetch function in our repository as a suspend function. then do it in a regular way. And in our view model, we will create a live data builder with context of our view model scope, with dispatcher of IO to do it in the background. Then fetch data from our repository and emit it to this particular live data. And then do some transformation using mediator live data and handle result in the main thread, and then set it to the view as usual. Yeah, and another good thing that we can use one live data as a source. Let's see. For example, here is our room class DAO object, and here we get all recently viewed restaurants, and we receive not just a list of these restaurants but live data with this list. And in our repository we still create a live data builder, then emit source of this DAO object, a live data of this DAO object. Yeah, that's it. And another great thing about live data builder is that we can emit multiple values sequentially. For example, at first we emit the state loading, it shows this loading state. Then we receive some items from our database, and then emit source of this live data of the database. And also keep in mind that every time we call emit or emit source method, we remove our previous source and replace it with a new one. So in this case, when a new values came from our database, we emit the new success state with the list. Oh yeah, talking about live data, we're also talking about limitation. First of all, yeah, we can't use it for sequentially. Actually, we can use, but we can rely on only the last value that I show you in example of when I show you activity and view model on create method. Then live data is lifecycle aware. For sure, yeah, we can use observe forever method to rid of these lifecycle aware things, but I think it's not the best practice. And live data is for main thread for sure. Yeah, can we use something better in our domain layer? Because yeah, all this limitation. Unfortunately, yeah, we can use Kotlin Flow, and this solution can really help us. Before we start, let's recap our knowledge about Kotlin Flow. What exactly is Kotlin Flow? First of all, the asynchronous stream of values. And for these asynchronous streams, we use coroutines, which quite useful. And then flows are sequential. It means we emit some value. Then this value go through all the step of this sequence, and then consumed in our collect method. And only then we send and emit the new value. And now we can create a flow using flow builder or as flow extension for iterator. And now our architecture is slightly different because we use flow for use case if we have some and repository basically in for our model. But in this case, we still use live data between view and view model. Let's see how to use flow. So here is a migration from our previous step when we decide to use a live data in our repository to flow in repository. First of all, this is a suspend method in our retrofit class. Then our previous implementation using live data builder, and then our now implementation using flow. Whereas difference? In this case, only words. Replace live data with flow, that's it. But there is a better solution. As far as we use flow, we can use the sequence. The practice is the same as we do using RxJava. So let's transform our big flow builder with sequence. First of all, emit some values that we received from the API, then map these values and convert it to some objects that we need. Then in our case, we put it to success state. And before we call API, we set loading state. Also, we can catch exception. If we catch exception, we emit state of errors. And another great thing when we use sequence, we can change our dispatchers during execution this way. And talking about flow, we also keep in mind that about upstream, just a bit about downstream. So in terms of upstream, it means that if we call some operator, this operator will affect all lines above. For example, in the last line, we have a flow on operator, which change our dispatcher to default for computation. And this operator will affect all of line above. It means before we face the next flow on operator. So everything that is highlighted, executed in default dispatcher, then we change dispatcher to IO and call API in IO dispatcher. Pretty simple. And for repository, I show you that we can use it, but can we observe these values in our view model? First of all, in our view model, we can create a live data builder with context that we need, in our case, view model scope and context of our view model. Then we fetch our data from repository using this flow, and then we collect these states from our flow and emit it to this particular live data. We can simplify it and use extension function for it. But handling errors, it's not pretty simple using flow, because thinking about upstream. In this method, in this case, our catch operator can handle errors only in highlighted blocks because it affects only the line that above this catch operator. And if do something in collect block, our application will be crashed. But how we can do it better? We can use empty collect block and move everything from the collect operator to on each operator and put it before our catch operator. That's it, simple. Now we can handle errors in do something method. Also, great thing that flow support back pressure by default, but let's better to read some articles by Roman Elizarov instead of I will tell you everything about it. And maybe we can use the flow for between view and view model, and don't use live data everywhere, live data for this case. Actually, we can, but to be fair with you, we did not try to use it in production, but think about this solution. So here is a dependency that we need and which provide lifecycle coroutine scope for us for activity fragment. And also this lifecycle scope support three base method to when our activity or fragment created, started, and resumed. So how can we use it? So in this case, our view model expose flow instead of live data, and we collect these states from this state flow in our on each method and launch this collecting with lifecycle scope. Or we can start when our activity is resumed and then collect states in a regular way. Also, some suitable case for us to use state flow instead of just regular flow because state flow is pretty the same as a live data, but it know nothing about life cycle for sure. But in our view model, we can fetch flow, regular flow, with launch it with view model scope, and in our binder or fragment or activity, we can launch when our activity or fragment resumed, and collect these values depends on the scope of activity or fragment. And as far as I mentioned RxJava in my title of this presentation, I have to have at least one slide to compare Flow and RxJava. So in terms of operators, for sure, RxJava have a lot of operators, and Kotlin now don't have some useful operator like share, publish, repeat, group by, parallel. But yeah, I think we will have these operators in some time. Then in terms of threading, it's easier to work with Kotlin Flow because we keep in mind only about upstream, just a bit about downstream. And using RxJava, we're also thinking about downstream, upstream, everything can affect everything. For nested dispatchers and nested schedulers, which we use in, for example, switch map on flat map, it's easier to use Flow. Also, we have the same setup for subjects. In Kotlin Flow, we have a state flow and channels, and in RxJava, we have a behavior and publish subjects. Yeah, Kotlin flows that I mentioned support back pressure and by default, and RxJava, yeah, in turn have a flowable type. And also, Kotlin Flow is officially supported by JetBrains and Google, and many libraries support this flow. Yeah, instead of using third-party libraries, you can support it by default. So summarize, I think Kotlin Flow is more easier to us to use for some common operator and common cases. And yeah, there is some things in our code base like things and classes that we use for the whole application, like a user service, authorization, or card service. The things that use application scope, not the scope of our activity or fragment, but yeah, we use it for the whole application. And yeah, let's think maybe there is also option to use workers in application scope instead of use flow channels of live data for these global things. Yeah, and as I said, almost everything that I showed you in this presentation we use in production for years. So yeah, we can use these technologies. And also everything that I showed you in this on my slides, you can compile and find this code in my repository. And if you have some questions, you can contact me. Yeah, feel free to ask. Thank you.
Well, thanks, Alexey. Thanks you so much for your presentation. I actually found it absolutely superb and really fantastic. Appreciated also the level of detail that you went into and showing the architecture and how it works. Would you have a couple questions? I'm going to ask Jan to put the Slido questions on the screen here, so he should be able to. We should be able to see those shortly here coming up. And there we go. Okay. Oh, we just lost him. Okay.
Okay. Brilliant. What's absurd? You can show an example. Yeah, actually, you can find all of example of the code that I shared in my repository. You can find it using the link that I shared in the last of my presentation. Yeah. If you have an app that has been developed for over 3 years and that use RxJava heavily, have transformed such app to Kotlin Flow and coroutines? Oh, actually, it's a big deal for sure, because you know, if you use RxJava, it affects any part of your code. But fortunately, Kotlin Flow has the same name of operator like you have in RxJava, and you can just for some cases just replace observer method with flow block, and that's it, and then do line by line. But for many cases you can just replace your observe block with flow. Hope you answered. What's the difference between flow and state flow? Yeah, actually flow, it's common class, and the state flow is designed pretty similar like live data in terms of state flow keeps the state, last state. You can do the same things like for live data, set value in some different period of time, and but yeah, for sure state flow know nothing about life cycle. And state flow is the same like a subject in RxJava, if you know. Okay, if you have an app that have been okay, I think we can move to the next question. Can we get a link for, okay. Same, I'm calling the API to fetch a list. Should I still use flow to pass data from repo to view model, or I can just pass the data object directly as code is now sync? Yeah, you have two options. If you decided to send only just one value, you can mark this function method in your repo as a suspend function and call it directly. But if you need some sequential values, send a list of status, like in my example. First of all, you can firstly you send loading states and success state and etc. Yeah, it's better to use flow. Okay, super talk, thanks. Please answer. Which app website you use it for slides? Yeah, it's basically Keynote. Okay. Hello, really nice talk. Thank you. Thank you too. I wanted to ask you, okay, Flow is still on experimental. Any ideas when it will come stable or is secure to use in production app development? So actually, I'm not aware where it will be stable, but some big part of this Flow framework, I think it's stable, and just only not just a few methods that we used in our project mark as experimental some operators for this flow, but generally I think we can use it because we use it. Okay, can you use flow with data bindings? No, I'm not sure actually, because data bindings is easier to use with live data, and with flow I think you will need some your class in the middle of your flow and your view. Say I'm calling the API to fetch a list. Should I use flow to pass? Yeah, I already answered this question, the first one. Okay, in the shopping app, where would you use flow? So everywhere where you use RxJava and this flow of your RxJava, actually, when you call API, transform some data, maybe you observe some events from your interface. In terms of, if you use MVI architecture, you can use flow to observe events from our view. We're also thinking about creating MVI architecture for our project and migrate from MVM to MVI. And for view layer, we use state flow in current case. If you don't need a stream of objects, but just a list of, for example, why use flow over a simple list? Yeah, if you need just a simple list, you can use a regular suspend function with and cover it with coroutine, and that's it. If you need some transformation, it's useful to use flow for sure, but don't make your code overcomplicated with use flow everywhere. Please explain view model scope and live data builder. Which one should I use with flow? Okay, so view model scope, it means it's a coroutine scope for your view model, and it means we can launch some coroutines with this scope, and these coroutines will be automatically assigned to this scope. And when our view model will be created, destroyed, cleared, basically, we stop and cancel all of assigned coroutine. That's it. Yeah. I hope I have already answered.
Well, all right, Alexey, it looks like that is the end of our presentation here. So let's see. Really appreciate you being here and your detailed work on that. That was fantastic. Let's see here. I'm gonna get myself as a moderator. So, there we go. Just wanted to make sure that people knew what's coming up next year on August 3rd. Again, thanks to Monika, thanks to Alexey for being part of this. We really appreciate you both being here. And again, we look forward to seeing you here next week, August 20th, for part 3 of our Advanced Kotlin series. And as I had mentioned in the beginning, we had a little bit of problem with the with transferring at the beginning here, but you can see all of the presentations on droidcon.com. We'll have a video of this. It'll be audio indexing, so you can search it. So those will be online tomorrow or the next day. And we look forward to seeing you all back. Again, many thanks to our speakers. And we'll see you next time for another webinar as part of our droidcon Online series. Thanks so much, and everyone have a great day. Bye-bye.